Chemical sedimentary rocks are made mostly from the precipitation of ions out of solution. Although, just to confuse you a little bit, there are some clastic chemical sedimentary rocks as well. I'll show you some examples of those too. But most of the materials that go into these are derived from chemical weathering. So when we have those dissolved ions from chemical weathering, we can have it reprecipitated out inorganically, or we can actually have biochemical where animals are involved, and I'll show you what those look like. So the most common type of chemical sedimentary rock is called limestone. So here's an example of the limestone on the left there for you. It's a calcium carbonate, and it has lots of calcite in it, so it will actually react with acid. That's one of the easiest ways to identify limestone. These are formed in marine settings. I always say when you think of limestone, I want you to think of Finding Nemo, but the first part where he's in the anemone, and not the last part where he's in the dentist office, right? But coral reefs, really warm, shallow marine. This is where you have lots of little critters with calcium carbonate shells that can contribute to that limestone. The picture on the top is a beautiful example of a limestone outcrop. This is another Texas location for you. These are the Guadalupe Mountains out in West Texas. This is actually the rock where Carlsbad Caverns has actually been weathered out of, which is kind of cool. This is actually the highest point in Texas if you're into that. It's Guadalupe Peak. It is a whopping like 2,000 feet above sea level. Now there's some special types of limestone that are worth mentioning just because they're kind of cool. So coquina is a type of limestone made mostly of shells. And since our point here with all our sedimentary rocks is to make sure and think of an environment, what's an environment that you could think of that would have lots and lots of just shell pieces? How about a beach? So a beach that's made mostly of shells is going to give you a coquina. Ways to recognize this, at least when I was taking physical geology, we said it looks a lot like oatmeal, little flecks of oatmeal, so that makes it a little easier to recognize. Another limestone is called chalk. Now you've hopefully written with chalk at some point in your life, and there's a picture there on the bottom right. Most of that's synthetic, but chalk's a real material. It's a type of limestone, and it's made out of an accumulation of shells of algae, protists, and phytoplankton. One of those phytoplanktons, and one of my favorites, is this little critter on the right here. That's a coccolithophore. So these, have you ever heard there's a nursery rhyme, and it's how does your garden grow? Oh, Mary, Mary, there you go. Mary, Mary, quite contrary, how does your garden grow? With silver bells and cockle shells and pretty maids all in a row. Well, the cockle shells, and that is a type of flower, but they're named after cockle shells, which you can find in the ocean. And so is this, because you've got these little plates that look kind of like cockle shells. And when this little guy dies, all those plates fall apart and drift down to the bottom of the ocean and start building up over time. And you find a lot of that out in the really deep ocean, away from a lot of terrigenous sediments, where this is all that's building up, and we have a bunch of that like dead critter stuff at the bottom. It's called an ooze, which is beautiful, and that ooze ends up hardening into and lithifying into limestone. Here's a really famous outcrop of chalk for you, though, the White Cliffs of Dover in the English Channel. It's the shortest crossing between England and France. And the picture here doesn't actually do it justice, just how white those cliffs are. Here's a picture of a piece of chalk. It's white and chalky feeling. An inorganic limestone, which means it's not directly made from the critters, is an oolitic limestone. It's actually little sand-sized balls of calcium carbonate. Now how this forms is you have maybe a broken shell that's in a bay where the waves wash back and forth. That's kind of one of the big things, is having that water, that current sloshing back and forth. And that little shell rolls back and forth with the current. And as it does, it starts picking up little bits of calcium carbonate that's dissolved in the water, and it accumulates around. And it rolls back in a little bit more, and then it rolls back a little bit more. And they're sort of known for these. Here's a micro photograph of one of these. And you can see the layers built up over time in these oolitic limestones. Looks kind of like Dippin' Dots ice cream. There are sandbars, I think in the Bahamas, that are actually made out of just balls of oolites, which is very cool. One more, we have travertine. So travertines are formed in caves. So slightly acidic water goes running through your limestone, dissolves out calcium carbonate. Those ions are now in the water. They drip in a cave, and it leaves behind the calcium carbonate, and you end up with cave formations or speleothems. These are travertine. Here's some examples of beautiful ones. On the right, you've got stalactites. You've got stalagmites that are down there, and when those two meet, it's called a column, and you've got a little bit of flowstone going on there. When we talk about groundwater, we'll talk a little bit more about caves. The one on the left just looks kind of cool. It's a helictite. It's a type of like a type of stalactite, but it makes these weird shapes, probably due to air pressure changes. All right, we're going to step back a little bit, and we're going to look at another type of rock. So we're moving away from the limestones. This is a dolostone. It's made mostly of the mineral dolomite. So it's a calcium magnesium carbonate. So the only difference between this and a limestone is that it has magnesium. Makes it a little harder, makes it a little denser. It also makes it where it doesn't react as easily with acid. What's interesting is if you have a dolostone, you can take one of the steel nails and scratch the surface of it until you get like little bits of powdered dolostone. That will react pretty easily with acid. Now, these form in a Silica environment. So this is a place where the ocean's being quickly evaporated. So a Silica, it's an Arabic term. So it may help you actually figure out what kind of areas this forms in. So the Persian Gulf is a great place, and all around the Arabian Peninsula is a great place to find these. Here's another one. This is Namibia. So you've got a desert, those beautiful desert dunes, right up against the ocean. Super high levels of evaporation here. And in those cases, that magnesium works its way into the system where you would normally get maybe a limestone just offshore. You actually get a dolostone instead. All right, here's an example of some outcrops, what these look like. These are the Dolomite Mountains in Italy. This is actually where the name comes from, since they're made mostly out of dolostone. Beautiful, right? Now, another type of rock, this is actually pretty common too, is chert. If you've ever seen an agate or a jasper, or if you've seen those slices of rocks that look cool with like bands and stuff on them, maybe at a store or at a rock show, that's just different types of chert. So chert's a cryptocrystalline quartz. So it's basically all silica. So silica is its composition in this case. So we're moving into a different composition even. Now this is created when you have microscopic critters that have silica tests or shells. A couple of those are my favorites. On the top, these are radiolarans. They look like glass sculptures, but they're made out of silica, which is basically quartz. The bottom is diatoms. Often these are described as pillboxes because it's got two little shells that slide together. But chert tends to be cold, and it tends to break. And when it breaks along really sharp edges. Because if you remember, quartz didn't have any cleavage, but it does have a conchoidal fracture. Well, chert does too, and you get really sharp blades. So that's why you find a lot of arrowheads made out of chert. Interestingly, somebody who does flint knapping, knows what they're doing and can do this, can actually make blades on a chert that are sharper than surgical steel knives, which is actually kind of terrifying if you ask me. But it makes it a little easier to recognize that way. We also have evaporite minerals. These are going to form where you have water evaporating. So playa lakes are a great place to find these. We'll talk about what a playa lake is in one of the next videos. But two really common sedimentary rocks that form in these. You have halite, which is there on the left. Those are beautiful pink examples from Corona, California. Or on the right, you have gypsum. Gypsum is super soft. If you remember from when we did minerals, you can scratch it with your fingernail. It's what makes up wallboard or drywall in your house. On the bottom is a couple of great examples, the Great Salt Lake and the Bonneville Salt Flats. These are actually what's left over of a giant glacial lake that used to cover a good portion of Utah. There you go. It's Lake Bonneville. So This is how big the lake actually used to be. And the Great Salt Lake is what's left of it, because all of that water is evaporated away, and that's why it's so salty, is because all the salt that was in it, a fairly freshwater lake at the time, has been concentrated in what's left. And the Great Salt Lake is getting smaller and smaller as we go. Here's one of my favorite examples of a gypsum crystal, though. Now, you may have seen this picture before, but these are a set of caves in Mexico that was discovered by a Mexican mining company full of these giant gypsum crystals. And if you look, there's a person for scale. These are ridiculous. They're enormous. It's pretty cool. This used to be full of sulfuric acid fluids. So it was super hot sulfuric acid. The mining company was working close to that and actually accidentally popped it and drained it, and then they found all these, which is pretty awesome. Here's another sort of interesting deposit of gypsum, and it's in these cracks right here. So if gypsum forms when water evaporates, that means there was probably water that seeped into those cracks at some time. This image is actually from Mars. So this is one of our pieces of evidence that Mars actually had water at some point. One more kind of cool place with some of this. This is the White Sands of the White Sands National Monument in New Mexico. In this case, there's a giant gypsum deposit just outside of the national park, and the wind blows and it actually weathers, the gypsum weathers away and is transported in sand-sized pieces, and they build up into these beautiful pure white sand dunes. It's a very cool place. One last one of these that don't really fit. This is kind of our big organic rock, coal. It's a sedimentary rock. So coal is made of plant matter, twigs, leaves, branches, any kind of plant parts. And so it all piles up. Now normally when a plant dies, if a tree falls in the woods and nobody's there to hear it, it's going to start breaking down anyway, and it's returned sort of to soil over time. But in an anaerobic environment, that means it doesn't have enough oxygen and you don't have bacteria that's breaking it down. So the trees just sit there and they get buried. So a place with really low oxygen, even lots of plants, is a swamp. So this swampy area is where you get coal seams in. During the Pennsylvanian and Mississippian times here in the U.S., if you look at your geologic time scale, those are times that actually we were covered in lots and lots of swampy forests, which is why there's lots and lots of coal in Pennsylvania. All right, there's 4 types of coal. There's peat, which isn't really coal because it's mostly just squished in plants. You got lignite and bituminous coal. These are the 2 you can burn. Bituminous is the one you want. And when it's squeezed enough, it actually turns into a metamorphic rock, and that's what anthracite coal is. It doesn't burn very well. Bituminous is really what most power plants are using. Alrighty, one last look at some beautiful limestone. This is actually a piece of the limestone that makes up the San Jacinto Monument down in southern Texas. It's the monument to the very last battle of the Texas fight for independence from Mexico. Lots of beautiful shells there in it. All right, thank you. And we will look at some other sedimentary processes.